Expansion in solid. Now expansion in solid can be splitted into three. We have what we call the linear expansivity, let's say alpha. We have area expansivity, let's say beta, and we have the cubic of volume expansivity. Let's say gamma. Let me use this as my gamma. Now what is now linear expansivity? What is linear expansivity? So linear expansivity, this is the change. Linear expansivity of a substance is the increase in length. This is the increase in length per unit length. This is the increase in length or change in length, increase in length per unit length per degree rise in temperature, per degree rise in temperature. Linear expansivity is the increase in length per unit length per degree rise in temperature. That means linear expansivity alpha is equal to increase in length. That means change in length per unit length over length per degree rising. That's like, let me write the English first. Is equals to, okay, let me write it in English. Let's see. Linear expansivity is equals to change in length or increase in length, like I've said, increase in length per unit length over original length, then times rise in temperature. That's temperature rise times temperature rise. So you can say this less alpha equals to increase in length, change in length per unit length. Let's say the original length is L naught per degree rise in temperature as change in theta. Now change in length is going to be new length minus original length. That will be new length minus original length. So that means before I talked about that, this is going to be like my change in length is equal to what? Alpha L naught change in theta. Alpha L naught change in theta. Now, but my change in length is equal to new length minus original length. Let me say my new length is L1. That means my change in length will be equal to L1 minus original length is what? L naught. If I put into this equation, I will be having L1 minus L naught equals to alpha L naught change in theta. That means my new length L1, will now be equals to, okay, my new length, let me use the other page. That means my new length L1, that means my new length L1, since we have new length L1 minus original length L naught equals to alpha L naught change in theta. So this now be equals to L1, the new length, is equals to L naught plus alpha L naught change in theta. So L naught is common. Like I can say my new length L1 equals to L naught into 1 plus alpha change in theta. So this is formula for your new length. at 41 degrees Celsius. What will be its length? What will be its length at 30 degrees Celsius? We are given that the linear expansivity of glass is equals to 2.0 times 10 raised to power minus 5 times 10 raised to power minus 5 per Kelvin. So we want to find the new length. So we want to just find the new. So just solution now. What were we given? We are given the length of the well, that's L naught is equal to 10 meters long. Then my initial temperature T1 is equal to 41 degrees Celsius. Then my theta 2 is equal to 30 degrees Celsius. So I'm waiting for the new length. What will be the length? The new length. So that means you apply the formula. New length L1 equals to L naught into 1 plus alpha change in theta. So this will give you what? Your L1 equals L naught is what? 10. Open bracket 1 plus alpha is going to be what? 2.0 times 10 raised minus 5. Then change in theta will be what? It will be 41 minus, no, theta 2 minus theta 1, sorry. Theta 2 minus theta 1, and that will be what? 30 minus 41. So this will be equal to 10 into bracket 1 plus 2.0 times 10 raised minus 5. 30 minus 41 is what?
Minus 11.
Minus 11. That's times minus 11. So this will give you 10. Open bracket 1. This will be minus 11 times 2 is minus 22. That's minus 22 times 10 raised to power minus 5. So press the calculator, what will this give us?
Zero point 99978.
So that will be 10 times 0.99978, right? So your answer will now be what?
999.
9.99978 meters. So this is the new length. So that will be the new length. These are we together?
Yes, sir.